Hello, and welcome to the first episode of an unnamed podcast slash interview series that I'm doing with professionals in the Rust space. I'll start with an introduction of myself, and then we'll ask my guests to introduce themselves as well. But yeah, my name's Cedric. I head up the Rust team here at Understanding Recruitment. I've been helping build teams in the Rust space for the last 4 years, which is quite crazy to think. I mean, 4 years ago, what was Rust really? It wasn't even a thing, and here we are,
Yeah.
a couple of years down the line, and finally we're starting to see some traction there. I have enjoyed every single moment of being in this community, and yeah, this kind of interview series and podcast, or I don't know what we want to call it, but it's just a way for me to kind of give back, have some professionals talk through their experiences in Rust and the wider surrounding areas, and yeah, give back and hopefully start some comments on a post and get people interacting and engaging with each other. But yeah, that's my background. I'm sure we'll learn a bit more about myself. It's not really about me, it's about my guests. So yes, if you wouldn't mind introducing yourself to everyone out there.
Awesome. Thank you very much, first of all, Cedric, for having me. This is my first time doing this as well, so we just roll with the punches with it. But really briefly, my name is Eugene, or if you wanted to pronounce it natively, it's Eugene. And I'm currently the head of engineering at Exein, which is a cybersecurity startup based in Rome, Italy, which uses Rust through and through for the past 2 to 3 years. All the way from the platform engineering product side of things, all the way down to the systems engineering and the software that actually runs on embedded devices, whether it is Linux, FreeRTOS, ESP devices, and so forth. So really the domain at which we actually use Rust is very wide, and we do use it extensively, and something we've enjoyed very much as well over the past couple of years, I would say.
Lovely. And what was the stack beforehand, or do you not, or are you not sure?
We were no, we previously it was mostly Python for the most part with a bit of Go. We do still have a Python service for a very
Mm-hmm.
specific reason due to some dependencies and so forth, but we've, for the most part, migrated all the stuff to Rust. And anything new and moving forward has always been Rust, which comes with its own sort of trade-offs. But we tried to keep it exclusive to Rust for a number of reasons, even just from an operational standpoint. So we try not to mix and match too much in terms of what we use. So far, it's paid dividends. So we have pretty much no complaints with it. But you would have to actually acknowledge and be like intellectually honest and acknowledge the trade-offs that come with it, because there could be some which might not be super obvious to many people.
Okay, cool, nice. And like, I assume it's here to stay. You don't see it kind of shifting back into anything else?
I would say Rust has been, and I've just to give some context, I've been a fan of Rust and followed it pre 1.0, right? So if you Google something like path exists Rust, you will find my Stack Overflow question from like 8 years back, right? So I've always followed Rust very, very closely, and I've been very, very interested in it. Because to me, and even back at the time, to me, it felt like a step change, right? This was not simply a different, a slightly different angle to really solve these problems, but really a paradigm shift in terms of how we thought about these things and where you align the language as a tool in a wide spectrum of different languages. And Rust was very uniquely positioned in terms of the guarantees it provided, the performance it provided, and really some properties that it provided as a byproduct of these two things, right?
Mm-hmm.
So Rust is one of those things that I do believe with certainty will stay, and not only will it stay, it's one of those things that will really expand in scope and really embed itself in different areas. There are areas where I see perhaps a more diverse ecosystem, but for
Mm-hmm.
many other places, I do see it really taking a piece of the pie, so to speak.
Good. I mean, I hope so. we've been working in this community for long enough. I think it's time that we start seeing that expansion kicking in a little bit. But
Yeah.
what kind of other areas do you foresee it kind of growing into? Obviously, like historically, or I suppose from where people perceive the language, it's just a back end, dirty back end language that can handle all
Mhm.
this performance and processing power. But is there any other areas in which you foresee like this starting to gain a bit more popularity?
I mean, I can only speak for the areas that I touch and sort of I keep an eye out on. And the embedded space is still very early in terms of
Hmm.
an ecosystem perspective, right? So think of these are industries that are very static. They're not, if you have to draw comparison to something like front end, which is a very fluid ecosystem that changes year to year. If you look at the embedded space, it's a far more static domain. So taking away from that is extremely expensive because there are lots of things that have been ingrained in those spaces, which now Rust is starting to take a part of. I would say that Rust would be a bigger and bigger part of the embedded space, and it's a part that we focus on quite a bit. General backend is also one of those areas which you'll see larger and larger adoption. And another place where I believe you're going to start seeing a lot of this is sort of the bridge or the intersection between academia and industry, right? And Rust really positioned itself in a very nice spot here, I believe, where if you look historically, you generally would have languages that fall into either of two categories. You either had the academic ones, you think like Haskell, and then you'd have more industry focused, things like C# and C++. You had some which were in between, so they were very pragmatic on academic grounds. So if you think Erlang, that would be an example of it.
Okay.
But Rust is one of those where it really sits nicely in the middle, where you can very neatly, you can quite neatly, let's put it that way, translate academic papers into actual code that is both sound and performant and can be adopted by industry folks, which is it's something that's very, very rare, right? So you could do it in Haskell, but then you've got a problem of distribution and ecosystem and developers and so on. Or you could do it in something like C# or C++, something more imperative, but then you didn't have the soundness guarantees or the correctness guarantees that you would have with something like Haskell. Whereas Rust, you really sit in between, which is to me one of the most interesting spots to be in.
Yeah, 100%. I suppose the only counter I've experienced in this time is, and it's just I don't know if it's true or not. Like I'm not technically inclined, but for a lot of people, it's been really difficult to pick up and learn unless you've come from a certain kind of background at the moment. But what's kind of your take on the learning curve with Rust?
100%. That's probably the most difficult part. And that's generally the price to pay. And it's important to acknowledge it as a price to pay in the sense that you need, you can try to wrap it neatly and try to say, oh no, it's super easy. And it is to get started. It could be super easy, but the moment you try to do anything, you will feel an amount of friction that you generally don't feel with other languages, right? And this, I feel, is if you had to boil it down, is the necessity to almost speak and interact with the compiler, which you learn to love. And it's generally one of the most beautiful parts of the language, which is you feel like you're having a conversation with the compiler, as opposed to this very disjoint, hey, this is what I would like to happen, versus this is what actually happened to the machine. You can really tap into the compiler and say, you know what, you normally would lay out the memory for this struct in such a way. I know that I'm going to be running this on this particular CPU with this particular cache size, so I want to force the memory layout to be such, for instance. And you can do this so intuitively and so neatly. And when you get that to work and when you have that intuition, it's simply one of the best feelings in terms of software engineering that I can find. Yeah, that's how I see. What I would also say, my background is actually not systems engineering related. So I have no experience in the past with C++ or C, for instance. My experience was with Python, memory managed language like Python and Java. So the way you had to the transition from those languages to something like Rust is extremely, extremely difficult. To the point where I did try to pick up Rust and I dropped it multiple times before I became what I would call productive. Let's say, equally or more or less productive to how I was with Python, for instance. So if I had to look back, and I'd say one of the flaws in my approach to learning it was trying to learn Rust directly as opposed to trying to learn some of the primitives of, just how pointers worked, for instance. Very, very basic things, so nothing crazy. And then from that springboarding onto Rust and learning how to use it productively and intuitively and build nice things with it, I would say.
Yeah, Okay, interesting. It's interesting that you dropped it a couple of times before you came back to it.
Yeah.
I think from what I understand, most people kind of give up and then just leave it. I suppose you had an overriding need to kind of carry on with it.
If I can add to that, it's also there were, I would say, two key points. So I didn't even come from a building background in the sense I was more on the just exploiting systems was actually my background. So the more breaking things. And the first turning point for me was actually building a few exploits in Rust, very network related exploits. Was the first turning point. So if anyone from security, which is probably going to be a big demographic. So if I had to go back to the previous question, security is a big place where I'll see Rust taking part in.
Mm-hmm.
A lot of security folks are very good at building, very hacky things, but that, have some very specific exploit or some very specific function. And for me, the first turning point was building my first exploit, which was like this TCP SYN flood thing in Rust. That was the very first. And then I was like, okay, here's something concrete. It's nothing crazy. It's just a file that does something very specific. That was the first sort of key milestone. And the second key milestone was then taking a step further, still in the security domain, because you don't want to change too many things at the same time. So stick to the security domain and now build a library, but that's security focused. So security focused library, which is like this domain permutation. So a way to like squat domains, right? So you have google.com, you want to permute all the possible variations of google.com that you might want to hijack, essentially.
Yeah.
And that was the second milestone, so to speak. And then from there, it really just, once it clicks, the beauty of it is once it clicks, it really just works. And you start to just think in a certain manner and have sort of this mental framework to be productive with Rust. I would find going back to anything else not very difficult, but I would generally now I'd feel the friction the other way.
Sure. Is that why I keep hearing I'm never going back again? Rust is my life. This is it. It's almost like a weird cult at times. People don't want to go back and they have a taste for it and just kind of stay.
I generally take a different approach with this. I am very much a fan of Rust, but it is a tool like any other. And you have to acknowledge it for that, right? So I always focus more on just engineering primitives and just good engineering practices. And you generally want to find tools that lend themselves well to really adopt those practices, right? And Rust is one of those tools. So I wouldn't say, and at the same time, so this is where the difference comes in industry, where in industry you need to ship and you are operating, essentially your goal is to enable the business to achieve its mission, whatever that mission may be, right? So when people try to pitch Rust inside an organization, they tend to go gung-ho with technical reasons why we should do this, where you should really take a step back, look at the bigger picture, and really think like, should you adopt Rust? So what I would mention is that it's fine to take it for personal projects, and you generally won't go away. You won't go back to anything else, most likely. I'd still use Python for quite a few things, very quick and hacky, a good prototype. But for personal projects, I wouldn't go back to something like Java, for instance. Personally, I'm not saying Java is bad. It's just I have invested enough into Rust where it is now productive enough to go with it. But when it comes to working in an organization, you might need to go back to other things, and you need to be a versatile enough engineer to be able to do that. Right. So that's what I would mention to folks, which is it's good to love Rust. It's extremely good, but ultimately you are achieving what the organization wants with what the organization has. So you need to keep that in mind as well.
Yeah, very interesting point. I mean, for a lot of, let's say, the fans then who want their companies to adopt Rust, it's interesting because, there needs to obviously be a business case behind it as to why. How would you, let's say Exein weren't using Rust at the moment, but you're like, I'm a big proponent of it. How would you pitch to the powers that be, hey, we need to be using Rust, and why, right? Because you're absolutely right. It's a big issue from a technical perspective. This is amazing. This is great. This will help everything. But, as you work your way up the chain, it probably becomes less about, is it technically great? Who really cares? Like, what is the purpose behind this? What would this win? So, very shortly, how would you, I suppose, pitch it up to people?
So if we had to take, if we had to take Exein as a specific example,
Yeah.
so you can break it up into many parts. So the business can be broken up into many parts. And one of those parts is interacting with, so we're providing a security solution. So that's the first point. And we're providing a security solution to embedded systems, right? So these are low resource, highly constrained environments, and you need to be very, very particular. Now, we use another technology called eBPF, pardon me. But the problem is, let's say you did it in C. You suddenly, the moment you want to go to the market and speak to customers and you tell them, hey, listen, I want you to install my agent onto your system in ring 0 or in user space in C, where you might have panics and leaks, you have a lot of friction. So the immediate, if I were to pitch Rust to leadership in that scenario, it would be purely a basis of, this is a USP. This is something that the market would want, because now you can go to these folks who are technically inclined, and you can say, we can give you something that is very high performance or low overhead, however you want to pitch it, provides memory guarantees, right? And we can interact with the kernel in a very safe way through other technologies which also provide these guarantees. Right? So you've completely moved the angle from, oh, it has borrowing and ownership, which is interesting, but you have to pitch this to an organization to think of byproducts of these properties. They don't care necessarily about lifetimes and ownership and borrowing and so on. They care about what these lead to. So I would say focus on those things, for instance. Another area which is very good is where the problem domain is very static. So a problem domain that does not change all too much, which is important because there's an upfront cost to development with Rust. It does take more time to build things. So if you're trying to pitch this for some e-commerce API that is going to change, or some reporting API that's going to change every single day, it might not, you're going to have a very tough time. But if you were to go to say, let's say you're doing, I don't know, I used to work in online gambling before, because where I'm from, that's like the big thing.
Sure.
And let's say you have a betting engine, right? A betting engine is a very static domain. There's a very defined, well-defined ahead of time expectation of what the system does. And that is not bound to change very much. So now you can grab this static domain and you can say, okay, I can use Rust to now reduce the overhead, memory, and so on, and reduce costs and increase performance. And you quantify those, and then that's a very easy pitch to sell, right? So it's generally, you have to think about these different angles. You have to be a salesperson, quite frankly, less of an engineer, more of a salesperson, and say, like, what are you giving to the business ultimately? Yeah. That's how I would generally approach that. Yeah.
No, great. That's really helpful, because I think, we need to think a bit more as a community in making this more commercialized and used professionally. There's usually a champion at a company who loves Rust, plays around it in their own time, and then they go, we should really be doing this, starts implementing one or two little things into their work that has some Rust there, and we start seeing this has got some good use actually. But that's very slow burning, and I think I get a sense from the community, a bit of like we need some more urgency in trying to push this through and make it happen, and I think that's quite interesting for us to kind of talk through. So cool. And then in specific, like, how's work been going at Exein? What kind of things have you guys been working on there that you think might be interesting to talk about?
I would generally break it down. So we have many parts of the organization, as we mentioned, but I would generally break down two very interesting parts that we work on from an engineering standpoint, obviously.
Sure.
Which is the embedded systems engineering side. And that is more Rust running on these small devices. And the other is more the sort of cloud platform that we build, which is like this real-time data streaming platform, which is also built in Rust, and we use particular patterns there. And they're both very, very interesting for very different reasons. The systems engineering side, so the low-level stuff, that's just a work of art, and we open sourced the framework called Pulsar that all of these are built on top of, which is using essentially eBPF and Rust. eBPF is this kernel technology that allows you to peek into kernel behavior in real time without the security implications of that. So historically, if you wanted to see that, You either had to operate very slowly in user space, or you could be very fast in kernel space, but you'd have issues where if you crash, you can crash the kernel, which is a big, big, big no-no. You should never do that. So what we do there with Pulsar is very, very, very interesting. The Rust that the team has produced to actually develop that, you can see it for yourself, is of extremely high quality, which is really an inspiration even to myself when I'm learning new things. I really use that as a basis of, this is the topic I want to learn next, for instance. So Rust has been an extremely advantageous proponent of that project, which I would say has been extremely successful so far. From the cloud side has been actually really interesting, because we were initially a bit worried that it was going to be very slow to iterate on. But with the way Rust works, and with really well laid out workspaces, we almost have our own small ecosystem of libraries internally that we build for different services. And Rust lends itself really well to that. So we almost have this mono repo set up, if you wish, where we've used Rust to essentially build this. We use this pattern called CQRS, Command Query Responsibility Segregation, where the system is divided into two halves. You've got the half that writes data and the half that reads data. And you need these two things to really, like the scaling needs to be independent of each other, right? Because imagine yourself, you might have 1,000, 10,000, 100,000 devices in the wild connecting to a platform, sending events in real time. So, hey, listen, someone opened a file. I received a network connection. I'm making a DNS request. These are all events that get fired in real time. And then on the other end, you're a single individual who needs to read that data, but in ways that are interesting, right? So you need to have some correlation and aggregation. So the way we do that is we use Rust and the CQRS pattern, where we have a queue and we use timescale.db to actually sort of do that. So agents can send events as frequently as they need to. We don't put any back pressure. And then we can gradually trickle them back to the dashboard as quickly as possible. And Rust has been phenomenal in that, because we have extremely low overhead, both from the edge all the way to internal services, right? To the point where normally the bottlenecks are other external services, not so much our internal ones. And Rust has been phenomenal in that aspect, and really a joy to work with, because it's the one beautiful thing about it is the stability of these services. The cost is upfront, but once you ship, you generally shipped, right? Yep. So you don't have to worry about lots of bugs in runtime like I used to with Python, for instance.
Yeah. Which is amazing, isn't it, really? When you really think about it, like the idea that even well, from what I've been told, you can write some good-ish Rust and it will do a great job, but you won't even really have to ever worry about it again. Whereas in other languages, obviously, you do always kind of have to keep worrying and like working on top of it, really. So, and if you write eventually incredibly good Rust, then hey, the sky's the limit, right? Which is quite cool. Yeah. I love that.
Yeah.
And like obviously your position now at the company and kind of what you look after, like how many people fall in your remit? Like how many kind of?
We are a team of 7 at the moment. So it's not a big team, but we're pretty much all seniors at this point. So this is another thing you have to also factor in is the seniority of the team, where you're actually proposing Rust. I should have mentioned this previously, where all the engineers have full autonomy into the parts of the business that they own. So some might be engineering, some might be parts of the platform, some might be systems engineering. And they all, the whole purpose in my case is give them full autonomy, because they're all seniors. So even if there's a gap in knowledge, they're very quick to both quantify that gap and close it, right? Which perhaps with more junior developers, that might be a bit more difficult. And there's this sort of inflection point where if it becomes too difficult, you end up burning out. So you need to be careful in pushing Rust in those scenarios. Right. So in my case, we're all senior engineers who have some experience in this area, whether it's systems engineering or Rust specifically. So in that case, it's a lot easier for me to actually work with these folks, which are extremely brilliant. They're far better than I am in terms of Rust as well, because they're far more specialized in the areas that they focus on. So I do learn a lot every single day from them. And The nice thing about this is I get to be in the trenches with them. So I'm building these things with them, as opposed to, you know, ivory tower overlooking and so on. It's a very different experience. And my objective is really just from time to time, pull them, make sure they see the forest, and then they go back to the focusing on the trees, right? So that's generally my objective. And at the same time, learning as much as I can with them. So my management to engineering ratio right now is in the Goldilocks zone, I would say. So it's like a 80-20 split, I would say,
Nice.
which is very, very good. Yeah.
Yeah, perfect. And how do you find it? Because where is everyone based? Everyone's distributed remotely, right?
We're mostly remote. We do have offices in Rome. So
Okay.
that's sort of our headquarters. And we do meet from time to time, quite frequently. We all gather up in the office just to spend time together, have activities and so forth. But other than that, we're mostly distributed around Europe, East Europe, Mediterranean, like myself. And so we work pretty much remotely. So we're a remote first company, especially from the engineering side, which has challenges because you need to think about things. You need to order things in very particular ways. But same thing, when you're mostly seniors, the friction is much, much lower than perhaps with other teams because we're very small. Everyone knows what everyone does, but we also communicate a lot between us. So from small things, I give the engineers 4 hours a week, for example, of R&D time. This can be anything they want to focus on. The only requirement is you have to write 3 bullet points on the channel. What did you read? Right. So to allow for this cross-pollination of ideas and so forth. And just having constant communication without the overhead of, hey, we need to have a daily stand-up or we need to do this. It's more of, let's gather up once a week all together. Let's get into focus and then disperse and let everyone does their thing. And then we communicate asynchronously
Nice.
between each other. Yeah.
Love that. I love that. I think that's the biggest challenge, obviously, when everyone's remote, is the communication side of things. Especially, let's say you were just adopting Rust now and you're all in it together learning. I can imagine that could be quite difficult. But like you said, when you've got a team full of seniors who kind of know their stuff, it's quite nice, and just let people crack on.
Yeah, I would say, and even if it doesn't have to be a team of seniors, because it's almost sounded like you need to be a team of seniors to use Rust. It doesn't need to be the case. What I mean by team of seniors is that we generally can learn the parts we need to learn independently. But if you're a team of even less experienced, pardon me, engineers, you can even just host workshops together. We used to, in my previous company, we used to host workshops together where I used to pitch Rust from a security standpoint to them and start with basics and just keep growing it together and do it a weekly thing or a bi-weekly where you say every 1 hour we get together and we just discuss Rust, for example. What did you work on? What did you work on? And just increase the awareness. And it's got this compounding effect, right? So it's a slow start, but once it starts, it goes. That's really something to acknowledge, as the early days, they're very difficult.
Yeah. Well, that leads on to what I was going to ask about, was like where you go to learn, where do you go to pick up on these things? Like, where's your kind of library? What do you kind of go to learn from?
Probably docs.rs is probably my main one, in the sense that that's generally where I go to now. But I would say I would generally classify it into 3 parts. Blog posts is a very big part of it and they're very interesting, as opposed to just asking questions, like, hey, I want to learn this or I want to learn that. Reading blog posts is nice because the topic is fed to you. So you're given topics that you just never would think about. Right. So that's a very, very good point. I would say blog posts are very, very important. So go to Lobster.rs or to Reddit or Hacker News and so on. Reddit and Lobster. Lobster.rs is very good for that stuff, where you just fed these topics and you just, going through them and just understanding, the wording of things and topics to focus on. The other one was actually, there was a series, Rust of Crust, by John Jenkset.
I don't know how to say his name. Yeah,
but everyone knows the guy. He has some really lovely streams because they're very detailed, to the point, about very specific topics, which to me sometimes it's very nice. If I'm doing something, I don't know, washing the dishes or whatever, it's very nice. I go in there and I'm just having it, I'm learning what channels are and I'm learning why send and sync are important. It's a very good space to learn that stuff, because it's same thing. in this case, you know what the topic is that you want to focus on, but what you are learning is then fed to you, so to speak. And the third one is just docs. Just really, this is more specific of I need to learn X, and I'm going to go to the root of it and just learn X, for example. And doing that is, I'll just say, get used to reading docs and reading like repos in general, like code bases. Just get accustomed to going through a code base, knowing how to find things out, because most people lay them out very intuitively. So just getting used to, docs and repos, getting used to those two, fantastic way to learn and build. For me personally, yeah.
Love that. Is there anything you're learning at the moment outside of the realms of Rust that has been interesting to you?
Definitely, I'm doing. I've got a Raspberry Pi 20 in front of me right now, and going and sort of. I don't know if you've ever heard of the Flipper Zero gadget. It's like the security device. It's really interesting. You can do a lot of